Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Patha Single, and this lesson is proudly brought to you by the Gauteng Department of Education. In today's lesson, we're going to be learning under the knowledge area matter and materials. We are starting a new topic, which is particle model of matter. The subtopic is the concept of the particle model of matter and change of state. Now let's go through the lesson objectives together. These are the goals we want to achieve by the end of the lesson. So at the end of the lesson, you should be able to define the particle model of matter, explain the different states of matter using the particle model of matter, explain what is meant by change of state, and describe the factors that affect the rate at which particles diffuse. Lastly, distinguish between the three states of matter. All this is sourced from your CAPS document on page 42. Pre-knowledge. So this is what we've learned prior to today's lesson. It has basically laid the foundation of today's lesson. In grade 6, we were introduced to the different states of matter, which are solid, liquid, and gases. Then so far in grade 8, we've learned under the topic atoms, the structure of atoms, the different subatomic particles that make an atom, and how atoms behave. Now let's move on to the baseline activity. I'm going to read out the questions and then give you time to answer them. After that, we will answer the questions together. Now I'll read the questions. Question 1. All matter is made up of tiny particles called blank. State which of the following samples show. There's sample A, sample B, sample C, and sample D. Does it show an element, a mixture, or a compound? And then question 3. What are the three states in which matter can exist? I'm going to give you 4 minutes to do this activity, and then after 4 minutes, we will go through the questions together. Don't forget to send in your responses for any questions you may have to our WhatsApp line, which is at the bottom of the screen. See you after 4 minutes. Welcome back, learners. Now, let's answer the questions together. All matter is made up of tiny particles called blank. Do you remember? These tiny particles are called atoms. They are called atoms. Question 2. State which of the following samples, sample A, sample B, sample C, and sample D, show an element, a mixture, or a compound. Right, let's see which samples show an element. It is sample A and sample B. Right, sample B shows individual atoms that are of the same kind. So remember, what's the definition of an element? An element is made up of, or a substance that is made up of atoms of only one kind. B is also an element. Why do we say that B is also an element? Remember, some atoms of some elements such as hydrogen, fluorine, oxygen, nitrogen exist naturally as diatomic molecules, which means we have two identical atoms that are bonded together. So these are diatomic molecules. They represent elements, for example, oxygen, hydrogen, and nitrogen. So A and B represent, or rather these samples show, an element. What about a mixture? B. What about a mixture? D shows us a mixture because what is a mixture? It's a substance, right, that is made up of, or rather that contains substances that one are not chemically bonded together and are mixed in any type of ratio. There is no fixed ratio in this particular situation. As you can see, all these elements or all these atoms of elements are not chemically bonded together. There is no fixed ratio as well. What about a compound? C, which one is showing us a compound? C is the one that is showing us a compound, right, where we have atoms belonging to different elements chemically bonded together in a fixed ratio. Number 3, what are the 3 states of matter, or rather, what are the 3 states in which matter can exist? It can exist as a solid, as a liquid, and gas. So solid, liquid, and gas. I'm going to give you 1 minute to copy down these corrections, and then after 1 minute we will continue with our lesson. Welcome back, learners. I'm sure you've copied down all the corrections. Don't forget to send any questions that you may have to our WhatsApp line, which is 079 578 and 2908. Now let's move on to terminology. So these are very important terms. We're going to be using them throughout the lesson, so it's best to find out what these terms mean. The first term, we have a technical error here. Sorry about that. The first term is solid. The first term is solid. A solid is a substance, or rather, a substance is a solid when it has a fixed shape that cannot be changed. A fixed shape that cannot be changed. Our next term is Liquid. A liquid, or rather a substance, is a liquid when it can be poured and takes the shape of the container. When it can be poured and takes the shape of the container. And then a gas. A gas is a substance that fills any space and cannot be seen. And cannot be seen. And then states of matter. What are they? They are the distinct forms in which matter can exist. Now let's go to the next slide. We have more terms to go through today. Vibrate. Vibrate. This is to move continuously and rapidly to and from. Melt. It is when a solid turns into a liquid. When a solid turns into a liquid. And then evaporate. Evaporate. When a liquid turns into a gas. When a liquid turns into a gas. Condense. Condense when a gas turns into a liquid. Solidify. Solidify when a liquid turns into a solid. Freeze. Freeze when a liquid turns into a solid. Now, let us begin. The particle model of matter. Now, the particle model of matter states that all matter, or rather matter, is made of tiny particles that are in constant random motion. And remember, the three states of matter are solids, liquids, and gases. And the particles that make up matter, they are in constant random motion. They are in constant random motion. So the particle model of matter is very useful because it enables us, or it helps us to explain the properties and behavior of materials by helping us to visualize what happens in a very small scale inside the materials. Remember, so far we've learned that all matter, if we look at this pen of mine, all matter is made up of tiny particles, and these tiny particles are called atoms, right? Now, so the particle model of matter helps us to understand what happens at a very small scale inside of the materials. Inside of the materials. The model does more than that. It also helps us to explain what happens during physical changes. What are these physical changes? They are melting, when a substance melts, freezing, for example, when a substance freezes, condensation, when a substance condenses, and evaporation. So the particle model of matter helps us to understand from a small scale when these physical changes happen, when evaporation happens, when condensation happens, when melting happens, and when freezing happens. Now, it is important to note this. It is important to note that the spaces between the particles is empty. What does empty mean? Empty means that there is nothing, which means these spaces, they do not contain air and they contain absolutely nothing. So remember, the spaces between the particles that make up all these different materials that we have, those spaces, there is nothing inside. There is not even air. Remember, air itself contains some gases, oxygen, nitrogen, and water vapor. Now, one more thing to note. I know we have said atoms are the smallest particle that makes up matter. So from now, we want to say atoms and molecules are referred to as particles in the particle model of matter. So don't be surprised when you hear me use the word particles instead of molecules or atoms. We are going to refer to atoms that make up substances, molecules that make up substances, molecules of compounds that make up substances as particles from henceforth. So we're going to refer these three as particles. We're going to refer to them as particles in the particle model of matter. Now let's go back in time. Let's go back to the 6th grade when we learned about the 3 states of matter. So the properties and behavior of matter depend on something. What is it? The arrangement of the particles. How are the particles arranged? Now, particles are arranged differently in the 3 states of matter. They are arranged differently in solids, they are arranged differently in gases, and they are arranged differently in liquids. Remember, these states are very different from each other. And one of the important differences is how particles are arranged within them, within the solid, within the gases, and within the liquids. Now, let's learn about each of these. We'll start off with the solids. Within the solids, so inside a solid, the arrangement of particles is quite unique. The particles are found very close to each other. The particles are very close to each other, and they are arranged in a definite regular pattern. And there are strong forces of attraction that hold the particles together. So these particles are very close to each other, and this is due to the strong forces of attraction that are holding these particles close together. So in solid particles, there is movement. Remember, the particle model of matter also describes that the particles are in constant random motion. So in solid, the particles vibrate in a fixed position and do not move much. So take for instance, if I am a particle within a solid, let's say I'm a particle within a solid, I'm not going to be moving from one point to the next. I'm just going to be vibrating in this one position. I'm just going to be vibrating in this one fixed position. So this is how the particles are arranged in solids and how they behave in terms of movement. So they vibrate in one fixed position. What else can we say about the arrangement of particles in solids? There are very small spaces between the particles because they are so closely packed. They are so close to each other. The spaces between the particles in solids are very small. So solids definitely have a definite shape and maintain their shape. My pen is a solid. It has a definite shape. Even if I squeeze it here or squeeze it there, it still maintains its shape. So here is a little short video just to show you particles within a solid. They are just vibrating in one fixed position. They are not moving from one position to another. They are vibrating in one fixed position. They are very close to each other, such that the spaces are very small. They are very, very small spaces. Remember, there's nothing in those spaces. There's absolutely nothing in those spaces that are there between the particles. And the forces of attraction between particle 1 and particle 2 is very, very strong. So it keeps the particles very, very close to each other. It keeps the particles very close to each other. Okay, all right. Now, if we look closely to this, sorry. I'm having a technical error here. Right. Liquids. In a liquid, particles are loosely arranged, but they are still quite close to each other. They are still quite close together, but they are loosely arranged. There are intermediate forces of attraction between the particles than in the solids. Remember, in the solid, what did we say? We said the particles, between the particles, there are strong forces of attraction that are holding the particles together. Now, with liquids are loosely arranged, which means now the forces of attraction are less than those within, or rather those of a solid. Now, particles in a liquid, they do something. They do move. They flow freely over one another. That's why you can pour a liquid. You can pour water from a glass to a different container because the particles can flow freely over one another. If we look at this little illustration there, see those particles, they are moving freely over one another. They are moving over one another. Next, particles in a liquid move at a faster rate in comparison to those of a solid. Liquids, therefore, do not have a definite shape. Does water have a shape? No. Does the cool drink that you drink have a shape? No. Rather, they take the shape of the part of the container which they would have filled. If they fill the entire container, they take the shape of the entire container. If they are filling just half of the container, they will take the shape of the bottom half of the container. Look here, this particular liquid, you can say it has filled 2/3 of the container, so it has taken the shape of 2/3 of the container. Next, gases. In a gas, particles are found far apart. So particles of a gas have a greater distance between each other in comparison to particles within a solid and particles within liquids. So the space between the particles in a gas is much larger than that of solids and liquids than that of solids and liquids. Now, when we come to talk about forces of attraction, the forces of attraction between the particles in a gas are very weak. They are the weakest compared to solids and liquids, and particles flow freely and fill up the available space. So if you release a gas in a room, it's going to fill the entire room from corner to corner. Okay, now there are some particles of a gas. As you can see, they are moving fast and randomly from one point to another. This is because the forces of attraction between them is very weak. Hence, the spaces between each particle becomes very large. It becomes very large. Now, particles move faster than those in the liquid state. They move faster than those in the liquid state. So they are moving randomly, and gases definitely don't have a definite shape. Remember, we're saying they fill up the space that is there. If you put them in a 500 milliliter container, they're going to fill up the 500 milliliter container. If you move the same gas to a 1 liter container, that gas is going to fill up that 1 liter container. Particles of a gas will fill up the available space. Now, next we're going to do an activity, our first activity of today's lesson. You need to complete the table below to compare the particles in solids, liquids, and gases. So we've got 3 columns. The first column is for solids, the second column is for liquids, and the third column is for gases. Now the description are written in the rows. Row number 1 talks about arrangement of particles. Row number 2 talks about the movement of particles. Row number 3 talks about the effective forces between the particles, the effect rather of attractive forces between the particles, and row number 4 talks about the space between the particles. So you need to fill in these spaces. The other spaces have already been filled up for you. Okay, I'm going to give you 5 minutes to complete this table, and then after 5 minutes we will do the corrections together. See you after 5 minutes. Welcome back, learners. Don't forget to send in your solutions to 079-578-2908. That's our WhatsApp number. Now, let us answer the questions together. Right, we'll start off with solids, then we move on to liquid, and then we move on to gases. We're going to be comparing the particles. Right, so arrangement of particles within solids, the arrangement of particles within solids. Solid particles, or rather the particles, are packed closely together and arranged in an organized pattern. What about movement? The particles vibrate. Movements are slow, so they vibrate in their fixed position. What is the effect of attractive forces between particles? The particles are held together strongly as a result of the attractive forces. So they are very strong. The forces of attraction are very strong and they hold the particles together very strongly. Now, what about the space between particles within a solid? The particles are very close together. They are close together. Now, let's move on to liquids. Let's move on to liquids. How are the particles arranged in liquids? They are randomly, or you can use the word loosely, arranged. What about movement? They move freely than solids. Remember, we said they can flow over each other. They can flow over each other. What about the forces of attraction? They are not held as strongly together in comparison to the solids. And the spaces are larger. They are larger. The spaces are larger between the particles. So the spaces between the particles are larger. Now let's move on to gases. They are not arranged in any specific way, and they move randomly around and spread out to fill the space. Remember, particles of a gas will fill the available space. They'll fill the available space. And then particles are not held together as strongly in comparison to liquids and solids. And the space between them is very large. Okay, take 2 minutes to copy down this table. Then see you after 2 minutes. Welcome back, learners. Welcome back. Now we are moving on to change of state. To change of state. What is a change of state? A change of state is a physical change in matter. These changes are reversible and they do not involve any changes in the chemical makeup of the matter. What are the examples of some of these changes? The common changes include melting, freezing, condensation, and evaporation. So these four changes are reversible and they don't involve any chemical change in the matter. Right, so I've got a diagram here. So when we talk of physical change, we're talking about change in the physical aspect of the matter. So when a solid changes into a liquid, or when a liquid changes into a gas, or when a gas changes into a liquid and a liquid changes into a solid. Now let's learn more about this change of state. Now, substances exist in three forms: the three states of matter: solid, liquid, gas. So, for example, when water freezes, it becomes a solid. We call that solid ice. And when ice melts, it becomes a liquid. When this liquid is heated, or when heat energy is added to the liquid, it starts to go through the process of evaporation. So it starts to evaporate and become a gas. We call these the three states of matter. When a solid melts, it becomes a liquid. When a liquid evaporates, it becomes a gas. When a gas condenses, it becomes a liquid. And when a liquid solidifies or freezes, it becomes a solid. All right. Now, when you heat or you cool a substance, it can cause the substance to change its state. And we can use the particle model of matter to explain what happens to the arrangement and movement of particles when it changes its state. So when energy is added to a substance, particles will move further apart until it changes its state. We added energy, particles are moving further apart. Adding energy makes particles move further apart because they've gained energy and they now have energy to overcome the forces of attraction that were keeping them in the original position in the first place. Now, when the opposite happens, when you remove energy from a substance, what happens is the forces of attraction between the particles become stronger and the particles move together until they change their state. So this diagram briefly explains what I've just said. So when you add energy, particles within a solid will gain energy. They gain energy until they get to a point where they overcome the forces of attraction that are keeping them close to each other, and then the space between the particles increases, the solid melts and becomes a liquid. If we continue adding energy and we add energy to the liquid, the forces of attraction that are holding the particles of the liquid together will become weak, and then the particles will be able to break free, increase the space between themselves, the liquid evaporates and becomes a gas. Water becomes water vapor. If the opposite happens, let's say we remove energy from water vapor. The forces of attraction between the particles within a water vapor are going to become stronger, bringing the particles closer together. The water vapor then condenses to liquid water. If we continue and remove more energy from there, what is going to happen? What happens is the water particles are going to move closer to each other until they get to a point where the water changes its state and becomes ice. Ice, the solid, which has particles that are very close to each other and has a rigid definite shape. Has a rigid, definite shape. Now let's talk about the four states of matter that I told you about, the four changes of state. Melting. Let's talk about melting. This is when a solid becomes a liquid. We say it has melted when a solid becomes a liquid. Okay. Now, what do we need in order to melt a solid? We need to add energy. So when energy is added, a solid becomes a liquid. The particles speed up. They gain energy. They start speeding up and moving faster. Temperature rises and the forces of attraction become weak. Once the forces of attraction become weak, then the solid will have reached what is called its melting point. It changes its state from solid to liquid. Here is a picture of ice that is melting. Look at that part there. This is the liquid part, and this is still the ice part that is yet to change. Now let's talk about evaporation. Evaporation. Okay. Now, if we add heat to a liquid, the atoms or the particles rather, they gain energy and start moving faster. Forces of attraction between the particles becomes weaker. They overcome these forces and evaporation occurs. Particles can then start escaping from the surface of the liquid if enough heat is added. So this marks the surface of the liquid. There we go. So if enough heat is added, the particles then can escape from the surface, and then this is the gas now. This is your water vapor now. This is your water vapor. It is your water vapor. Okay. All right. Now, condensation. Condensation, this is a change in state from a gas to a liquid, or rather cooling of a gas. This is when energy is removed, okay, and then particles begin to lose their energy. What happens? Forces of attraction become stronger, the spaces between the particles reduces, and then your gas condenses into a liquid. I'm sure you've seen when you boil water in a pot, those water droplets that are on the lid of the pot, that is water vapor that would have condensed on the lid of the pot. Now let's talk about freezing. Remember, we said when a liquid becomes a solid. This is when energy is removed, when there is loss of energy or the particles lose energy. They begin to slow down in their movement and the temperature cools. Forces of attraction between the particles become stronger. So the spaces between the particles reduces and the substance reaches what is called a freezing point, at which the temperature at which the substance becomes a solid, when water becomes ice, when a substance changes from its liquid form to a solid state. So it changes from its liquid state to a solid state. Okay, now let's move on to diffusion. What is diffusion? Diffusion is the process in which particles in liquids and gases move. They separate and they spread from a highly concentrated area to an area with a lower concentration of those particles, of those particular particles. All right. So this is diffusion. So we have these particles in an area where they are highly concentrated. Then they start to move to an area where they are at a lower concentration. That is what we call diffusion. So we've got diffusion in gases and diffusion in liquids. For example, when perfume is sprayed from one corner of the room, let's say you are in a room and someone sprays a perfume at the corner of the room. At first, if you are not in that particular space where the perfume was sprayed, you will not be able to smell it. But the gas particles from the perfume will gradually begin to move and separate and spread through other particles within the air. And then, which means they are moving from where they were highly concentrated. Where is that? The area where the perfume was sprayed, that particular corner. And then they start to move where? To an area with lower concentration, which is your nose. If you're standing opposite at an opposite corner, you will start to smell. This is a result of diffusion. So we have perfume particles being sprayed in one corner of the room, and then when diffusion happens, we have the perfume particles, the pink ones, and now they have filled up the room. Now everybody in the room can smell them. Now, what about diffusion in liquids? One example I can give is food coloring in water. So when you drop, or rather when food coloring is first dropped into water, the particles will be concentrated in one particular space. Now, because of the loose arrangement in liquids, now the food coloring particles are able to flow in the spaces between the water particles. Remember, there's nothing in the spaces between the water particles. So the food coloring particles can easily move and maneuver within those spaces. They will move gradually between or rather through the spaces of the water particles until they are evenly displaced. So this is point 1 when you drop the food coloring, point 2 as they continue to disperse, and point 3 if you leave it for longer without shaking or swirling the water, you will have the food coloring fully dispersed in the water. Now, what is the difference between the rate of diffusion in liquids and the rate of diffusion in gases? Now, diffusion in gases is faster in comparison to liquids. Why? This is because the particles of a gas are wider apart and they move faster than the particles of the liquid. That's why diffusion in gases is faster than the rate of diffusion in liquids. So this makes it easier for particles of a gas to move from one point to another because of one, the way they are arranged and the fact that they are in constant random motion and they move much faster than particles of a liquid. Now, what are some of the factors that affect the rate of diffusion? 1. The mass of the particles. Lighter particles will diffuse faster on average because they move faster. And the state of the particles. Particles of a gas are always moving fast. They are always moving fast. And we say they are moving at a speed that is high. Particles of a liquid in comparison with particles of a gas, they move at a slower rate. Temperature also affects the rate of diffusion. Temperature is a measure of how much kinetic energy these particles possess or how much kinetic energy these particles hold. So the higher the temperature, the more energy the particles have and the faster they move and diffuse. So temperature is very important in the rate of diffusion. Lastly, the spaces between the particles. If there are large spaces between the particles of one substance, the particles of another substance can move into those spaces easily. That's why when you drop food coloring in water and you spray a perfume in a room, the perfume particles quickly fill up the room at a faster rate in comparison to the food coloring that will be dropped in water. This is because of the spaces between the particles. The spaces between the particles in water are much smaller in comparison to the spaces between the particles in gases. All right, now let's move on to our second and final activity. The first question reads, define diffusion. The second question, in which media air or water does substances diffuse faster? And study the diagram below and fill the empty spaces. Right, I'm giving you 3 minutes to answer these questions. Then after 3 minutes, we will continue on it. Welcome back, learners. Now let's answer the questions together. Right. Define diffusion. Diffusion is the process in which particles in liquids and gases move from highly concentrated area to an area with a lower concentration of those particles. Right. In which medium is air or water do substances diffuse faster? So we're comparing air and water. It is, of course, air. So they diffuse faster in air. Why? The particles of a gas are wider apart and move faster than the particles of a liquid. That's why substances diffuse faster in air. And then study the diagram below and fill the empty spaces. So when a solid is heated, it becomes a liquid. When the liquid is heated, it becomes a gas. When a gas is cooled, it will become a liquid, and when a liquid is cooled, it will become a solid. So these are the three states of matter: solid, liquid, gas. So this is melting, evaporation, condensation, and freezing. Right. Now take 1 minute to copy the corrections, and then after 1 minute, we will wrap up our lesson. Welcome back, learners. Now let's wrap up our lesson. Now, what did we learn today? We learned about the particle model of matter. We learned about the three states in which matter exists and how the particle model of matter helps us to understand what happens within these three states of matter at a very, very small scale. The three states of matter are solids, liquid, and gas. And we also learned that the particle model of matter is based on these three important points. The first one, upon particle arrangement, how particles are arranged in solids. They are closely packed to each other. In liquids, they are more loosely packed, and in gases, they are further apart. The energy that the particles possess, gases possess the highest amount of energy as they move very fast. Liquids can freely flow on top of each other. That's why we can pour a liquid, and then solid particles have the least, as they can only vibrate within a fixed position. Now, we also learned about the distance between the particles in these three states. The particles of a solid are closely packed together. The spaces are very small. Within a liquid, they are more loosely spaced. There is some space between the particles, and then with gases, the particles are further apart. We also learned about diffusion, the process in which particles in liquids and gases move from a highly concentrated area to an area where they are at a lower concentration. We learned about diffusion in gases, that diffusion in gases is actually faster than diffusion in liquids. This is because of the energy that gas particles possess and the large spaces that are in between the gas particles. We also learned about the change of state between the three states of matter. When a solid is heated, it will melt into a liquid. When a liquid is heated, it will evaporate into a gas. When a gas is cooled, it will condense into a liquid. And when a liquid is cooled, it will freeze into a solid. All right. Now, here is our homework activity. Take 1 minute to copy down the questions. Then after 1 minute, we will call it a day. All right, learners, thank you so much for joining me in today's lesson, and I hope to see you in the next one. Bye-bye.